Let's introduce the concept of logistic regression, which is an important concept in learning statistics for public health, because in public health, we deal with morbidity and mortality. Did someone die or not? Is someone sick or not? These are binary variables that we're very interested in modeling and predicting and trying to figure out the determinants thereof. In order to predict binary outcomes, we can't use any of the tools that we've done before. We've talkt about using means, t-test, linear regression, multiple linear regression. We've talked about chi-square, where you can relate one categorical variable to another. We talk about non-parametric tests where some of the assumptions aren't met. But what about combining this sort of idea of a categorical variable with all of the powerful tools we learned in multiple linear regression? There is a tool that does this, and it's called logistic regression. Now, from a technical standpoint, the math behind logistic regression, it's very different. Logistic regression is not an answer or a formula. They're fit iteratively by the computer. And you can spend lots of time learning about logistic regression and the technical aspect of it. But from a practical standpoint, this is very similar to linear regression. And we can do a quick introduction that will have you interpreting logistic regression from the medical literature and even running some good logistic regression on your own. So like a linear regression, we are going to get some coefficients, slopes, betas. And what they're going to say is, how does X, changing X, relate to changing in Y? Now, we remember from 7th grade, rise over run. How much does X change? And how much does Y change when you change X? But here, things are going to be a little bit different because our outcome is now going to be binary. So think about everything you know about regression. Y equals A, the intercept, right? Plus B1, X1, a slope for some predictor, plus B2, X2, a slope for another predictor, as much as you want. All of that stuff is going to be the same, except we are now going to change this. We're going to change this side of the equation so that we have a 0, 1, or a binary variable. So we're going to have models. We're going to make predictions. Everything that's on the right side of the equation is going to be the same. They can be binary, continuous, categorical. We might just have one predictor, or we might have a lot. But what's different is the outcome is now binary. So instead of predicting the mean of Y, I'm going to wave my hands and black box some of this stuff. We're going to predict whether Y is equal to 1 or not. Here are some examples. These are research questions. They end with question marks. They start with good question words. How much does each cigarette that a person smokes increase their probability of getting lung cancer? The beginning of that sentence sounds really nice, like a slope. For every additional cigarette, right, as that X variable gets higher and higher, how does your Y variable change? The outcome. But this outcome is now getting. You either get it or you don't. So this cannot be done with any linear regression, but it's going to fit really nice into a logistic regression. And there's a very nice, specific sort of research question, and you'll look at what is that slope. Here's another one. Which of a variety of factors will predict whether a person will walk again after a broken hip? What is the outcome variable here? Walk again. You either walk again or you don't. Yes or no? Now, the variety of factors, we can put a bunch of stuff into the model. You probably had some fun playing with that. What is the best model? What goes in? What types of variables and so on? How about this? Can a person's gender, age, education, motivation, number of beers consumed per week, there's all of our predictors. Can they predict whether someone will pass a class? Yes or no? A binary variable. I think it's useful to stop at this point and see if you can come up with some of your own research questions that would be appropriately analyzed with a logistic regression. Think about some outcome that's a yes, no. Something where it's the, right? The. Morbidity, mortality. Come up with some potential research questions. It might be a simple logistic regression, which is one predictor, or a multiple logistic regression, where your research question will include words like, in phrases like after controlling for, after adjusting for, or holding constant. In the next set of slides, we'll look at how logistic regression works.